So this is our review of the end of term 4 test. I thought I would take you through this step by step so that you can see my thinking, where that's useful. I can give you some hints and tips as to the approach, and you can see what the answers are supposed to be. So, question 1, a student uses some everyday items to investigate static electricity, and it says, rubbing the plastic strip with a cloth causes the strip to become negatively charged. This happens because something moves from the cloth to the plastic strip. Well, it's always electrons that do the moving, so that's the answer here. In exams, if you talked about protons moving, that would actually cost you a mark. It's one of the rare places that examiners have to take marks off you if you say the wrong thing, and this is one of those. The cloth then will be left with a positive charge because it has lost negative electrons. And while I think about it, never talk about positive electrons at GCSE. They do exist, but don't talk about them because, again, in this context, positive electrons could lose you a mark, not just not gain you one, but lose you one. So, when the plastic strip is hung over the wooden rod, the two halves of the strip move equally from each other, equally away from each other. What two conclusions should the student make about the forces acting on the two halves of the plastic strip? Two conclusions. Read the question carefully, and the key words here are that they move equally away from each other. So the first thing you're going to say, they are equal distances, and so the forces are equal. And the second key word, away from, well, they are repulsive, or words to that effect. So you might have thought about saying something like balanced. It's not quite enough. You need to say that they are equal, and you also need to say that because they move away from each other, the forces are repulsive. So that's exam technique as much as knowledge there. So, which one of these materials would electrical charge move through most easily? Well, glass and rubber are both insulators. Aluminium is a conductor, and it's a conductor because it allows charge to flow through it. It has those free or delocalized electrons to allow that to happen. Question 2 then, a bit of radioactivity, nuclear physics. Americium-241 is an isotope of americium. Which of the isotopes given in the table below is not an isotope of americium? Look out for that. The word is in bold, trying to be helpful. So, which is not? Well, everything that has the same atomic number as americium is americium. It is the only one that has that atomic number. This one does not have the same atomic number as americium, 95. So the answer is B, and the reason is it is a different atomic number. The mass number of these two is the same. They're all different to this one, of course, but the only one that has the same atomic number, the one that doesn't have the same atomic number is B. The graph below shows how the number of americium-241 nuclei in the sample changes with time. How many years does it take for the number of americium-241 to decrease from 10,000 to 5,000? Well, 10,000 to 5,000 is there, and I reckon that's 2 small squares out from 400. 5 small squares is 100, so that's 440. If you read it as 430, the mark scheme allows that. I read it as 440, so that's fine. Between 420 and 440 is what is required there. Normally they allow half a small square, so you'd have a tolerance of plus or minus 10 normally. In this particular case, they're allowing 20, but routinely, normally, it is half a small square, and so it would be an allowance of 10 normally. So, question 3 then. Before starting this experiment, the student drew a graph of what they expected the pattern to look like. Describe it. Well, graph A is a straight line through the origin. And see, there's 2 marks for this. So if you say proportional, that will get you 2 marks. They want directly proportional. If you say linear, if you say as time increases, the temperature increases, these are worth 1 mark, but directly 1 mark, proportional 1 mark. Part 2 then, the student measures the room temperature. He then switched the heater on and measured the temperature of the block every 50 seconds, and this is the graph he got. Now, this graph shows a lower rise in temperature after 300 seconds compared to what he had expected. So, why might that be? Well, there's a number of reasons that you could give here. And I'm just going to bring the answers over rather than writing them all out again. So clearly here there is no allowance for energy being transferred from the block to the environment. There is no allowance for energy being used to change the temperature of the heater, the thermometer, as well as the block. So here are the things that you can say. These are all the practical points that you were careful to note when you actually did this practical, and you can see the importance of knowing these practicals really well here. So energy transfer from the block to the surroundings. Sun energy is used to warm the heater or the thermometer. You can't get credit for saying both of those, one or the other will do. The energy transfer to the surroundings is largely because the block isn't insulated. So you can say the block isn't insulated and therefore you have energy transfer to the surroundings. That's fine, that's 2 separate points, although they are related. You're making 2 separate points with that. And so there it is. I think I've copied those in twice. So, one reason that's generous in the sense that in reality, if you're asked about a required practical, you'd be expected to give a lot of detail. So if you're not able to give all of the reasons here, you need to do some work on that because you need to be able to give all of the reasons. It's not going to be a 1 mark question you're going to get here. It's going to be a 6 mark question. So just bear that in mind. The power of the heater is 50 watts. Calculate the energy supplied in 300 seconds. Well, the way you're going to be thinking here is 50 watts is 50 joules per second. So in 300 seconds, we have 50 times 300, and that gives us 15,000. And we have the units over here already, so that's fine. 15,000 joules. So there's 2 marks for this. 1 mark is for the 50 times 300. 1 mark is for the 15,000. The student uses the same heater to heat blocks of different metals, each time the heater is switched on for 300 seconds. So which one of these will heat up the most? And you're told the specific heat capacity. Now this is about understanding what this means. So it takes 900 joules to raise the temperature of 1 kilogram of aluminium by 1 degree C, whereas it only takes 130 joules to raise the temperature of 1 kilogram of lead by 1 degree C. And so if you supply 15,000 joules, the lead will heat up most. Lead. And of course, the reason is, as I said, each degree C needs less energy. And you'll notice that the question tells you that they have the same mass. Okay, so that is question 3. Question 4 then. The figure below shows a balloon filled with helium gas. Describe the movement of the particles of the helium gas inside the balloon. 2 marks. So we need to say 2 things about the movement. What do we know about gas molecules? Well, we know that the motion is random. They're bouncing around in no particular direction. There are gas molecules moving in all directions. And what else do we know? Well, this is a little bit harder, I think, and very often these 2-mark questions are like that. The first mark is obvious, the second one is less obvious. So what else do we know about the motion of gas molecules, apart from their direction? And I'm going to say direction there. What else do we know? What else could we talk about in terms of the movement? We could talk about direction. We could talk about speed. Do we know anything about the speed? Well, we know it's going to be different for different gas molecules. And we know that because the temperature of the gas is a measure of the average kinetic energy, which means some are faster than others. So they have different speeds. So, successfully negotiated that question. 2 marks, 2 points. Which name is given to the total kinetic and potential of all the particles of helium gas in the balloon? Well, we know that it's internal energy. That is the definition of internal energy. So if you didn't know that, well, frankly, you could have guessed, because you would have looked at that and said, well, these 2 are opposites in a sense. One of them is probably right then. But you should know. Make sure you know your definitions. There are not that many you need to know, but you need to know them. Make sure you do. And again, another thing you need to know, and remember I said that about 40% of your GCSE hinges on maths and the application of it. If you don't know your equations, then you've had it. So the equation, density is mass divided by volume. And then we do the calculation. We have a mass of 0.00254 kilograms and a volume of 0.0141. So you stick the mass in here and the volume in here, divide mass by volume, and you'll get 0.18. And the units kilograms per meter cubed. So again, you need to know your units, but in this case, actually, you could look at the calculation kilograms divided by meters cubed, kilograms meters cubed. The units are going to be kilograms per meter cubed. 0.18. Now notice that in this question, you could have got 1 mark for this, but if you didn't know this, you couldn't get this. And from an examiner point of view, if you write the wrong formula down here and you use it here, even if you get the right answer, you're still going to get nothing for the calculation. So you could shed a lot of marks. And remember, there are 5-mark calculations in the GCSE. If that hinges on you knowing an equation and you don't know it, it's 5 marks. Make sure you know your equations. Question 5 then. The figure below shows a slide in a children's playground. A child of mass 18 kilograms goes down the slide. The vertical distance from the top to the bottom is 2.5 meters. Calculate the decrease in gravitational potential energy. So again, here is an equation you need to know. So you're going to say that your gravitational potential energy, well, the change in it is mass times gravity times height. The mass is 18 kilograms. Gravity, we're told here, is 10. You'll be using 9.8 in the GCSE, but the question says 10, so we'll go with that. And 2.5 meters. So multiply all that together and you'll get 450. And the units down here, they're given to you already, joules. So 2 marks, but if you don't know your equation, nothing. The slide is made of plastic. The child becomes electrically charged when he goes down the slide. Explain why. And here we have 2 marks. Now, there could be more than 2 marks for this question, but what have we got? Well, we have friction between the slide and the child's clothes. You could talk about the child rubbing against the slide, or 2 insulators rubbing together, friction between 2 insulators, something like that. Causes electrons to transfer. Now at this point, I'm looking back at the question and I'm asking myself, do I know which of these 2 becomes negative? And I don't. It just says the child becomes electrically charged. So I don't have to say in which direction the electrons are moving, just that electrons are moving. So electrons transfer between the child and the slide. So 1 gains electrons becoming negative, or of course the other loses electrons becoming positive. So these are the 2 marking points that the mark scheme is looking for. This is perfectly valid, perfectly reasonable. If you've said that, it's good. So, going down the slide causes the child's hair to stand on end. What conclusion about the electrical charge on the child's hair can be made from this observation? Well, If they are standing on end, the hairs are repelling each other. So each hair must have the same charge. Let's make that really specific. Same sign, all positive, all negative. That's only one mark though. But you know that because the hairs are repelling each other and like charges repel. So there it is. Why would the child not become electrically charged if the slide was made of metal? Well, my thought is, I'll stick this in here. Metals are conductors. Charge would flow through it. So no charge would build up on the child. So this is the key point. You might neglect to mention that metals conduct, but say that as a consequence of that conduction you haven't mentioned. So charge would flow through it. So metals are conductors, 1 mark. Charge would flow through the metal, 1 mark. Either of those two. And if it was me, I would go on to say the so what. Even though there's only 1 mark, you're looking to say something for sure that's going to get you credit. So I would do that. Question 6. A student investigated how the pressure of a gas varied with the volume of the gas. Get rid of that if I can. Can't seem to. Okay. The student investigated how the pressure of the gas varied. What's the resolution of the syringe? Well, you can see on your own copy. The resolution is the smallest scale division that you can read, and so the answer is 1 centimetre cubed. You might reasonably argue you can read to half a scale division, but 1 centimetre cubed is a safe answer there. The student compressed the gas. What conclusion can the student make from the data in the graph? Well, this is an inverse proportion graph. That's what it is. And you know that inverse proportion means that the pressure equals some constant divided by the volume. So you know that pressure times volume will give you some constant. That is to say, it will give you the same answer every time. So if you say 200 times 8, for example, 200, 8. Well, that's 1600, right? So if this relationship is true, then if we did 160 times 10, we should get the same. And we do. Now, 2 points matching probably isn't quite enough. So If we looked at 180 and 8.8, that's 1584. And that's approximately equal to 1600. If you did each of these to 2 sig figs, you'd get 1600. So I would always try and do 3. The mark scheme asks for 2. This is not necessary from the point of view of supplying the answer. It's just me explaining where we're coming from. Okay, so inverse proportion, 1 mark, couple of points of evidence, 1 mark each for your 3 marks. Okay. Explain why the pressure of the gas increases as the gas is compressed. 4 marks. What do we mean by compressed? That's my first thought. The volume is reduced. So, what difference does that make? Well, it means that the gas molecules will collide with the walls of the container more frequently. And of course, each collision exerts a force on the walls. So we now have a greater force and pressure equals force divided by area. So there's my answer. Now, once we have done momentum, you'll be able to give a better explanation here, because really the force is down to the rate of change of momentum. When we come back to that, you'll have a better, complete answer to this question. But right now, that's where we're at. So, the volume is reduced, 1 mark. Gas molecules collide more frequently with the walls of the container, 1 mark. Each collision exerts a force on the walls, so we have greater force, and pressure is force over area. 1, 2, 3, 4, 5 points. 4 of those for 4 marks. Final question. So, final question then, question 7. The atoms of the isotope bismuth-212 decay by emitting either an alpha particle or a beta particle. The equation represents what happens when an atom of bismuth-212 decays by beta emission into an atom of polonium-212. The bismuth atom and the polonium atom have the same mass number. What is the mass number of an atom? Well, that is the total number of protons and neutrons in the nucleus. You want to be clear in what you're saying, that it is the inclusive total of protons and neutrons. And saying that it's in the nucleus makes clear to the examiner that you know that's where they reside. Beta decay does not cause the mass number of an atom to change. Well, the reason that happens, of course, is that a neutron decays into a proton and an electron, so overall the mass stays the same, because what you're doing is changing a neutron into a proton, so the total number of protons and neutrons hasn't changed. When an atom of bismuth-212 emits an alpha particle, the atom decays into an atom of thallium. An alpha particle is the same as a helium nucleus. The symbol below represents an alpha particle. The equation below represents the alpha decay of bismuth 212. Complete the equation by writing the correct numbers in each of the two boxes. So balancing nuclear equations, you're saying the number over here and these two added together have to be the same. The number over here and these two added together have to be the same. So this has to be 4 less than 212. It has to be 208. And this has to be 2 less than 83. It has to be 81. I can't actually write in these boxes. It is impossible for the alpha decay of bismuth 212 to produce the same element as the beta decay of bismuth 212. Well, the explanation is, of course, that the number of protons, or the atomic number, is what dictates the element. And because alpha decay and beta decay are as a consequence of a different number of protons being lost or gained. With alpha, you lose 2 protons. With beta, you end up gaining 1, a neutron becoming a proton. So it's simply impossible that you could end up with the same element. Starting with the same parent nucleus, you could not end up with the same element via alpha and beta decay.